We'll balance magnesium plus oxygen yields magnesium oxide.
Don't look directly at the light.
Oh, that's awesome.
I told you not to look directly at the light. Yeah, I know you did.
Around the side of your eye.
Don't look directly at the light again.
Okay. Is that like boiling?
No, it's burning. So what kind of reaction is it? This gray stuff on the lab counter. Okay?
First problem, you have to balance the diatomic oxygen to the magnesium oxide. So you double the magnesium oxide. That doubles your magnesium. That balances your equation. You have the same atoms on each side. It's a combustion reaction. Remember, once the formulas are balanced, you cannot change the subscripts to suit your balancing the equation. You have to add coefficients, those numbers in front of the formulas, to balance the equation. Here's a tough one. Isopropyl alcohol and oxygen yields carbon dioxide and water.
Okay, you got your split. You got your split. You got your water bottle with alcohol in it.
Holy crap!
We won't go step by step here, but note the odd number of oxygens and the even number of hydrogens. In that case, you've got to even out both before you can balance the equation. Remember, the yields arrow should be treated like an equal sign. The number of atoms have to be the same on both sides of the equation. Here we'll look at the formation of rust, or iron 3 oxide. With the equation, you'll notice that the oxygens are odd and even, so you've got to even them up, double the iron 3 oxide. That leads you to need 3 O2s and finally 4 irons to balance the equation. You're putting two things together, it's a combination reaction. Let's look at sodium and water yielding sodium hydroxide and hydrogen gas.
Okay, I've got an old scalpel. If anybody needs any minor surgery, we could arrange that. How big a piece should we use?
A big one.
Huge. Full enough to have.
Cut out that little piece and use the rest.
Yeah. Right there, that whole other side.
Man, use the whole big part.
You see, it's a silvery.
This is sodium.
Yeah, this is sodium. It's a silvery metal. It's very shiny. When you cut it, it's kind of oxidized. Let's get it in here.
Yeah.
Alright, now that was perfect. I couldn't have paid you to do better.
For this reaction, it's beneficial to think of water, H2O, as HOH. This gives you a hydrogen and a hydroxide. So even up the hydrogens, leaving the hydroxides to be evened up with the sodium hydroxide, and finally the sodium metal. This balances your equation, and it's a single replacement reaction. A little more complex, lead 2 nitrate plus potassium iodide yielding lead 2 iodide and potassium nitrate.
The choices you have, this is potassium iodide. So you get a nice yellow precipitate that's a solid. Okay? One of the products is lead 2 iodide, and that's what this yellow solid is. It's a lead 2 iodide.
Here's an example of how you've really got to keep the formulas balanced to balance your equation. I would even up the nitrates first, and that would lead to having to even up the potassiums. Remember to keep those polyatomic ions, like nitrates, as a unit. Don't split them up. That's a double replacement reaction. Let's break down hydrogen peroxide into oxygen and water.
Get a little bit of water, but this is the hydrogen peroxide. I've got hydrogen peroxide. Grandmother's hydrogen peroxide, we got it souped up a little bit. But it basically is a clear aqueous solution. And, you know, why do they put it in the brown bottle?
Because they want it.
So we don't make it a brine alcohol?
Well, that's a good idea. What do you say?
So the light doesn't get to it? Or?
Yeah, so the light doesn't get to it because hydrogen peroxide will react basically on its own and over time turn into oxygen and water. So if Grandma leaves the hydrogen peroxide bottle on the windowsill long enough, it would just turn into hydrogen, rather into oxygen and water. But it's really boring, as you can see. It just kind of sits there. Okay. So what we're going to use is a catalyst to speed the reaction up. Now, what does a catalyst do? What's it supposed to do? Yeah, it speeds it up. It doesn't necessarily heat it up or anything, but what it does in this case, manganese dioxide, which is a black powder, lowers the threshold, lowers the activation energy that's needed for the reaction to take place. So it's sitting here letting off a little bit of, a tiny bit of oxygen, but certainly it's going to take a lot longer than we want. So if we want to get the reaction going, we've got to jazz it up with some hydrogen peroxide. So you can see it starts bubbling right in the balloon. Yes, just like watching grass grow, isn't it? We have liftoff.
Here, notice there's an odd number of oxygens on the right-hand side of the equation. So we're going to double the H2O, which will lead to doubling the hydrogen peroxide, and that balances the equation. Decomposition reaction.
And don't try this at home.
Meow.